All right, 5 ways to think about fractions. Are you ready? Yes. Watch this. This is called high tech. How's that? Can you see this now? Is this okay, Bill? All right. Way number 1, you ready? Part whole. Let's go on to another way, ratio. Your quotient is another way. This is one of the sometimes least, or not least, but it's not given enough attention. We know that in school. The idea with quotients is we're dividing or partitioning. So for example, we have 4 pizzas, 3 people to share the pizzas. How much pizza should each person get? Okay? So notice to solve this problem, you're going to partition up the pizza. You're going to start dividing it up in some way and doling it out. So you're partitioning up the pizzas to give to the people. And when you do it, your kids naturally start to think about fair sharing and making sure everybody gets the same amount. That's something that you want to emphasize with the quotient idea. But here's the thing. For us as adults, we forget that when we dividing a number by another number is creating a fraction. Okay? So when I say we have 4 pizzas and we want to dole it out evenly to 3 people, I'm doing a division problem. I'm taking 4 and I'm dividing it by 3. Okay? This is something we can be doing all the time with kids. We can do lots of examples. And when we do these, like let's say with cookies, that's a common one, or brownies or whatever. And so, you have a party in the class and you've got brownies and you're going to divide them up among your 20 kids in your class. You can make these into math problems all the time. Candies to dole out, whatever it is. Anytime with fair sharing and you're sharing things, you're working with quotient type problems. Okay? Look for opportunities to do this. The reason why is we know from research on this that when children practice these types of problems, they're going to be better at adding and subtracting fractions when the denominators are not the same. So and this is just a quick aside, and I'm not going to hammer away on this, but if you focus mostly on part whole, it doesn't help kids as much to develop ideas that they need to be able to add and subtract fractions with unlike denominators. Okay? Because what do you need to be able to do to add and subtract fractions when the denominators are not the same? You get a common denominator, right? Well, to be able to do that, you have to understand equivalent fractions. Equivalent fractions means you have to be able to divide things up more and so forth. And so this idea lends itself to dividing things and thinking about how I can work with thirds and sixths and doing things like that, getting comfortable moving across sort of partitioning type things. So kids need to be partitioning things up a lot. So for example, here's just a quick example. I don't know if this is helpful. When we divide these up to share with 3 people, we can do it in lots of ways, right? So we could give each person 1 whole pizza, and then the last pizza we could divide into thirds. That'd be one way to do it, right? But notice we could start dividing each pizza into thirds right away and just do a fair share. So everybody gets a third, right? Everybody gets a third. Everybody gets a third of every pizza. We just keep sharing and dividing it up. But notice, I don't have to do thirds. I could maybe work with sixths. Now, I know you wouldn't do this normally, but you could. We could divide this into sixths and give each person a sixth at a time. Why did you do that? Common denominators. See, this is a big idea, is that, oh, wait a minute. Let's see if I can even draw this picture. So I could take this pizza, let's see, help me on, and divide it into thirds. Is that okay? But I can work with my thirds to make sixths. Am I doing okay? Now notice, and by doing it in two, now I'm colorblind, but most of y'all can see this, right? If I can see it. Okay, here's my original third, right? But check it out. I can see here that my 1/3 is the same as 2/6. So right away, by doing this, I'm developing the idea that 1/3 equals 2/6. When we start doling this out, like, okay, 1/6 here, 1/6 here, 1/6 here, we still have a half left, and I'm going to have to give everybody another 1/6 again, right? And so when we do the 2/6 to everybody, everybody's going to say, hey, that's the same as 1/3, because I got that. You could have just given each person a third, or you could do the thirds first and then do the 6th, and everybody would say, wow, 1/3 and 2/6 are the same. Notice that that's a lot easier than going, oh, take 1/3 and multiply by 2/2, and that gives you 2/6, and you know, what is that? But here we can, so this comes back to Lorenzo's idea again. We can visualize it now. It's real. We have an image that we can recall. Our students can see it, they can feel it, they can touch it. Notice this also really gets very concrete. When it's concrete for our students, it's always better. And everybody in here, I saw a couple of people doing, you guys know that because you're great teachers. Does that make sense? So this idea, partitioning, dividing stuff up and doling it out, fair sharing, is such a powerful way to develop this idea of fraction. Much stronger to help kids add and subtract fractions with unlike denominator. That's why you need to practice it. So a comparison model.
Early age.
Yes. So comparing numbers, like which number is bigger, like 3, this is 3 more than this, is a preliminary piece to this, because you have to be able to compare what's more, what's less. Actually, that's a big idea in early number. What's more, what's less. And that also really lends itself to fair share. Because kids need to be able to fair share, they have to know when something's more and when something's less. They also have to understand the equality. So you're getting at equality. That's a huge idea for young children. When something is equal, when is something equal? That's actually one of the key ideas in the early grades. How do you know when something's equal? How do you know when something's the same?
At what grade level did you say we should start with the fair share part?
Fair sharing starting in kindergarten for sure. And you can start with simple things like candies. And so there's 10 kids in your class, you have 20 pieces of candies. And so, but notice the way you would probably do it. You would dole them out one at a time, right? And what you're doing then is you're building this fair share model as you're doing that. And kids get that right away. Why? Because they're all about being fair. I need to get as much as my neighbor, right? And so you're building on a natural impulse that they already have, which is fair. I need to get the same number as you. Here's another piece I want to point out. When you use different types of representations, see, this is the math way to think of it. Candies, okay, pizzas, brownies, circular things. Pizzas are circular. You know, a brownie pan would be rectangular. But candies are different, right? They're discrete objects. They're not continuous objects. Kids learn to think about number with different representation. Children need to get comfortable with different mathematical representations. Did you follow that? Do you want me to write that down, or does it make sense? Why don't you write that and just start down? I want to make sure everybody understands the idea. So you want to use circles, you want to use rectangles, but you also want to use discrete objects. That means objects you can count, like pieces of candy. So candies aren't connected to each other, right? They're separate from each other, so they're discrete. Children need to count and make sense of different representations. So, for example, I'm going to go back to part whole. Okay? If I have 3 green pieces of candy, and 2 that are, let's do 3 reds and 4 greens actually. Okay? So the question would be, actually this is a great question you could ask your kids. How many, so we lay out the candies, 4 green, 3 red. How many of the candies are red? Notice I've asked this as a very open-ended question. Is everybody with me? How many of the candies are red? Pretty much every one of our young kids is going to say 3. But there's another answer. 3/7, okay? We're going to talk about this right away here when we get out the handouts. This is a different way to think about number. One way is called absolute. Absolute is we just count. There's 3 red. That's what young children will do, right? Young children will say 3. It's called absolute thinking, or also additive ways of thinking. They just they count, and the last number in the count is the number of red candies. 1, 2, 3. There's 3 red candies. But somebody said 3/7. I think it was you, Tilly. Did you say it? I heard your voice over there, I think. So that's a different way of thinking. Tilly, can you explain the way you thought about that?
Well, it's 3 out of the, well, the total amount is candy, and you're separating the red ones from the total amount.
Did everybody follow that? You thought in a part-whole way. She looked at the whole, right? Okay. This is called a relative way of thinking. It's looking at the entire whole, okay? Now, young children don't do that, do they? It's not natural. It's just easier, and I think this is something we want to be aware of. It's easier to just count the number of reds, isn't it? I mean, that seems obvious to us, and there's nothing wrong with that. But, and this is something to be aware of, especially first, second grade, third grade for sure. Moving children away from just counting, I mean, that's certainly one way. There's nothing wrong with it. But beginning to see the whole, like, okay, 3 is correct, but how many are there whole? How many candies total are there? Well, there's only 3 of the 7, so we could say that 3/7 of the candies are red. That's just another way to think of it, okay? Doing examples like that with your kids is really important because it moves them into another way of thinking that's going to be important for them when they do multiplication and division problems. Okay, it turns out, why do kids struggle with multiplication and division? It's a different way of thinking. You have to think about groups of elements. You're thinking a little bit more holistically when you start to do that. Okay? That's something so just keep that in mind. You can do these types of examples all the time. But notice that the way I drew the picture and the question I asked, how many reds are there? It lent itself to a certain way of thinking, didn't it? Notice that this is very different from when I draw the pizza or when I draw this. The mathematical model lends itself to different ways of thinking. Are you with me? That's why we need to use different models.